Now that you've watched the video discussing the different types of angles formed by a transversal that cuts two parallel lines, let's actually put that math into action and see if we can figure out some missing angles that we have. You should have your notes packet open to 7-2, and let's do number 4 and 5 together, then I'll have you do 6 on your own. Number 4, we have two parallel lines. So this is a parallel line, and it's parallel to the bottom line, cut by the transversal. We have a couple of pieces of information that we know, such as our two obtuse angles here measure 150 degrees. There are a couple of ways that we can solve this to figure out all the missing angles in the picture here. And there's no right or wrong way, but this is just how I do it. I start by labeling the vertical angles, and if you remember, the vertical angles are the ones that are directly across from each other. So 150 is vertical to this blank angle here. Since they're vertical to each other, we know that they have the same measure. This angle here is 150 degrees, and again I'll do another vertical angle down in the bottom part, and that is also 150 degrees. Now the next part that we need to figure out are the acute angles in our picture. And if you'll notice, 150 degrees and that acute angle are adjacent to each other, and they form a straight line. If you remember from the video, adjacent angles are supplementary because they form that straight line. Supplementary means they add up to 180 degrees. To find the missing angle, that acute angle measurement, I need to take 180 degrees minus 150 degrees to find out that my acute angles measure 30 degrees. So I focused on that particular acute angle. Now if I do my vertical angles here, I know that 30 is vertical to this blank angle here, this other acute angle right across from it. So I know that that angle is 30 degrees as well. Okay, so how do I figure out the two acute angles in the top picture? Well, there are a couple of ways that you could do that. You could do adjacent angles again and figure out that they're 30 degrees, or you can focus on corresponding angles. And in the video, the speaker liked to draw circles around the groups of intersecting lines so that you know that each sector of that pie is the same from this group here to this group here. So since this angle here is 150 degrees, this angle here is 150 degrees because they're in the same spot. Those are called corresponding angles. I have 30 degrees here, so the same spot in the circle group above, this is 30 degrees and that's 30 degrees. And again, for the last measure, if this is 30 degrees, then that piece up there in the same spot, in the corresponding spot, is 30 degrees. And what we've done is from knowing two angles, we were able to find all of the other 6 angle measurements in that picture. It's pretty cool. All right, let's try number 5. Number 5 is very similar in how we're going to go about solving it. But this time, instead of knowing 2 angles, we only know 1. And we can actually still figure out everything that we need to know from that one angle. I like to start with vertical angles, so I look at the angle that I know is 135 degrees. Vertical angles are angles that share only the vertex. They're straight across from it, diagonal. They don't share any sides. Also, the vertical angle in this picture is the other obtuse angle. This obtuse angle is 135 degrees. I'm going to use my knowledge of adjacent angles to figure out what the acute angle would be right next to or adjacent to 135 degrees. I know that two adjacent angles, their bases form a straight line, and that a straight line has 180 degrees. So all adjacent angles combine to be 180 degrees. I'm going to do 180 minus 135 to find out that my acute angle there, my adjacent angle, would be 45 degrees in measure. I'm going to use my vertical angle knowledge to fill out the other acute angle. So that acute angle is 45 degrees. Once I filled out those 4 combinations of angles, I'm going to put my little circle around them, and I'll do the same thing up here. And I can use my knowledge of corresponding angles to help me fill out the missing pieces. I'm focusing on this small little wedge right here in this circle, this little acute angle, and I need to find its corresponding angle in the second circle. This piece right here is in the same spot, so I know that that angle is corresponding to my 45 degrees. That means that this acute angle is also 45 degrees. I can use my vertical angle knowledge and know that that other acute angle straight across from it, sharing the vertex, is also 45 degrees. Could also think about, hey, this little piece right here in the first circle is 45 degrees, so the wedge that corresponds to it in the second circle is also 45 degrees. And that means that the obtuse angle, the bigger wedge of my circle, is 135 degrees. And if I'm finding my corresponding wedge in the top circle, that means that my obtuse angle up here is also 135 degrees. And my vertical angle to that would also be 135 degrees. So that's how you take your angle relationships that we studied in the first video, and we can figure out from even just one angle measure, we can figure out all 7 of the other angles that are formed by a transversal that cuts 2 parallel lines. These are some of my very favorite math problems. I hope you enjoy solving them.